Okay, this is how you would do problem number 21, A. We're going to do problem 21, A, B, and C in this little tutorial. Let's just find the coordinates of the centroid. Well, the centroid is really easy. It's a simple formula. It's basically just the average of the 3 points given. So it's going to be the centroid is going to equal the average of the x's. An average, there are 3 x's, -1, 5, 2, divided by the number of numbers, which is 3. And then there are 3 y points. We can divide those by 3. So -1 plus 5 plus 2 is 6 over 3. 5 plus 5 plus -1 is 9 over 3. So your centroid is actually at 2, 3. You could find the equations of the medians and then calculate the intersection, but we won't do that here. All right. Orthocenter. These are going to be a little bit different, a little bit more easier, simply because this line here is perfectly horizontal. And if you talk about a line perpendicular to that, it's going to be perfectly vertical. So we're going to actually figure out 2 lines, 2 altitudes, because orthocenter is the intersection of altitudes. Okay, so we're going to figure out the equations of 2 different altitudes and then figure out where they intersect. So we're going to find the altitude to side AB, which is going to be actually kind of easy simply because you know the equation of AB is a horizontal line. So I know the slope of AB is just 0, right? So y equals 5 is the equation of that line. So basically what I'm looking for is the equation of a straight vertical line through the point to -1. So a straight vertical line through to -1 has an equation of simply x equals 2. So before I even have to do much work, I already got the altitude to AB. I could find the altitude to AC, for example, and this might be a little bit more work, but it's not much. So altitude to AC, I need the point and a slope. The point is going to be, I'm sorry, I drew the altitude to BC, so they're going to call this the altitude to BC, rather. So this side, and I need point A, which is -1, 5, and I need the slope of BC, and I need to take its opposite reciprocal. So I need the opposite reciprocal, so my slope will be the opposite reciprocal of BC. So the slope of BC is going to be 5 minus -1, all over 5 minus 2, so 6 over 3, which is 2. So my slope is going to be -1/2. My point is -1, 5, so now I just found an equation. So y equals mx plus b. Y is 5, m is -1/2, x is -1, and I'm looking for b. So 5 equals +1/2 plus b, subtract the half. So b ends up being 4.5 or 4.5. So my equation for the altitude, therefore, would be y equals -1/2 x plus 4.5. Well, now it's kind of nice because I got 2 equations where I have to figure out where they intersect. So if I'm looking at this, it's going to be y equals -1/2. We're just going to plug in 2 because I already know the x coordinate of the altitude and where the altitudes meet must be, because I'm looking for the orthocenter, it must be 2 something because x is always 2. So basically I'm trying to solve a system that looks like this, where x equals 2 and y equals -1/2 x plus 4.5. So if x equals 2, basically what I end up with is y equals -1 plus 4.5, or y equals 3.5. So therefore, the orthocenter is going to be 2, 3.5. Okay? So let's compare that with what you would do and what points you would use in the last one, which is the coordinates of the circumcenter. So the circumcenter is perpendicular bisectors. Okay? So I'm looking for the point where all 3 perpendicular bisectors intersect. So I already know basically that this line has a slope, or has an equation y equals 0, it has a slope, or sorry, y equals 5, it has a slope of 0, meaning I need to find the perpendicular bisector. Well, I already know that that slope's going to be undefined. I just got to figure out where this point is. So the perpendicular bisector to side AB, the point is the midpoint of AB. So it's the midpoint MPT of AB. So the midpoint of AB is just the average of 5 and -1. So 5 plus -1 is 4 divided by 2 is 2. 5 and 5 is 10 divided by 2 is 5. So basically what I have is a vertical line through this point to 5. Well, that's going to have an equation like we just saw in the last one of x equals 2. So I already got one of my two perpendicular bisectors. And just to keep it consistent, I already figured out what the slope of BC was from the last question. So I'm just going to use and find the perpendicular bisector of BC. The only difference is my point. I'm not going to use point A. Right? Point A is used when I find the altitudes. The perpendicular bisectors use the midpoint. So I need the midpoint, which is 5 plus 2 divided by 2, or 7 divided by 2, and then 5 plus -1, which is 4 divided by 2. So my point is going to be 7 halves 2. And just like we did when we talked about orthocenter, I'm going to use the opposite reciprocal of the slope of BC. So I already know from the last problem that the slope here is -1/2. So all I have to do is make up an equation and then figure out where these things intersect. So you see the difference is what point it goes through. Altitudes go through vertices, perpendicular bisectors go through midpoints. So therefore I'm going to just do y equals 2, m equals -1/2. 7 halves is x plus b. So this becomes -7 over 4 plus b. B ends up being, this is like 8 over 4, so 15 over 4 is b. So the equation is y equals -1/2 x plus 15 over 4. Well, now here's my two equations, and I got to figure out where they intersect. So basically what I do is I solve a system that looks like this. And we could use our calculators, but we can't really because we don't know how to plug x equals 2 into y equals, so we're just going to plug that in. I know whatever the intersection is, x is going to be 2. So this is how I solve it. So y equals, basically I get -1 plus 15/4. -1 is like -4/4. So to make these have the same denominator, I get positive 11/4 when I add these. So y is 11/4, x is 2. So my circumcenter, the point where the perpendicular bisectors intersect, is 2 and 11/4. All right, that was problem 21. I hope that helped you guys.